In this video, we're going to be explaining this problem about quadratics and graphing quadratics and parabolas in Algebra 1. The question states, what is the vertex of the graph of the equation y equals x squared plus 8x plus 23? So just a quick review of graphing quadratic here before we get right into the problem. When you graph a quadratic equation of the form y equals ax squared plus bx plus c, or equals 0 for that matter, you're going to get a curve called a parabola. This is a very bad drawing over here, but it does appear as a parabola, and this is what the general form of one would look like. The important thing to remember for this problem is that every parabola has a vertex point, and it's at the bottom of the curve where the two lines come together of the parabola, where the curve comes down at the bottom. In this case, it's this point right here at 5, negative 5. That's the vertex point. It's also important to note that it's you notice it's right in between the two wings of the parabola, if you want to call them that. It's right along the axis of symmetry, which you can just draw right here down the middle, right in between, in the middle there. It's also the midpoint between, if you had points here and a point here, the vertex would be the midpoint, this axis of symmetry here, right in the middle. That's going to be important to note for the concepts for this problem. That's pretty much all you need to know to solve this question, the axis of symmetry and the vertex point. And the vertex, oh yes, one more thing before we get started. The standard form of a graph of a quadratic is going to have h, k points. And the vertex point is always going to be in the form h, k. And there's actually a special standard form for a quadratic. And it's going to appear, just using variables here, something like this form. Y equals, in parentheses, say x plus 4 squared plus 9, something like that. That's a standard form for a quadratic, where our h in this case is the 4, and our k in this case is the 9. So in this situation, our vertex point would be 4, 9. Actually, no, negative 4, 9, because in the formula, it's never going to be a plus here. It's always going to be a minus. That's the standard form formula, so that's important. It needs to be negative 4, 9. So, we can now use this information to solve the problem. So we've got a regular quadratic equation here, x squared plus 8x plus 23, and they want to know the vertex point. Now, there's a very important and very useful fact about quadratic equations and parabolas that we need to know. The vertex point, as shown down here, is always going to be the average of the two solutions to a quadratic equation. And this makes sense because when you look at the graph, the vertex point is directly in between the two wings here. As we said earlier, it's the midpoint. So it makes sense the vertex point is always going to be the average of the two roots of a quadratic. Now, you already know, probably, that the average of the roots of quadratic is negative b over 2a. That's a formula, because when we're taking the average of something, we're adding it up and dividing it by the number of things. In this case, there are always going to be two roots. That's how we get the 2 there. So, we've got two roots here, and we've got our formula for the average. All we have to do is plug in our values for b and a. Our b, of course, is right here, the 8, and the coefficient of a is 1, the original 1 right here, the 1x squared, same as x squared. So, that gives us negative 8 over 2, which equals to negative 4. So, that's the average of our two roots of the quadratic, negative 4. So this tells us the x-coordinate of the vertex, just the x-coordinate, not the y-coordinate. You can see this if we go back over here to our graph and zoom in, because we've got, this is going to be on the x-axis here, this midpoint up here. The important part to remember is that it's the x-axis. The y-axis has no role in this. When we're talking about the vertex point, we're looking at the midpoint. The midpoint has to do with the x-axis. It's not governed by the y-axis. And so it makes sense that the average of the two roots will only tell us the x-coordinate of the vertex. So that's one part of the mystery right there. They want more, though. They want the entire vertex point with the y-coordinate. So from here, it's pretty simple. All we have to do is apply the completing the square technique. which is pretty simple if you already know it's actually very easy to do. You don't even need to do any complex math here. All you have to do is make a simple inference. Look at the equation here. X squared plus 8x. And then all you have to do is find out, well, which binomial, when multiplied together with the same exact binomial, is going to give us x squared plus 8x. So just some healthy small amount of trial and error will show that when you have the x plus 4 binomial, that's going to be 2 copies of these. You're going to wind up, if you multiply this through using the distributive property, you wind up with x squared, last terms, 4x, inner terms, another 4x. You're going to wind up, it's actually x plus 2 as a binomial. So that's the binomial you need to use to complete the square. So that's how you would get to that. All you have to do is look at the original quadratic and look at the coefficient of x, in this case the b, and think, what, you're completing a square, you're completing this binomial that basically makes this entire quadratic equation a perfect square. So that's why you need x plus 2 as the binomial. Multiply this through using distributive property, and you'll get what you're looking for. So, and using the completing a square technique makes this process a lot faster and a lot easier to go through, because otherwise you have to use a complex factoring method that may not even work, because we've got 23 here. That wouldn't work out too well with factoring. That's why completing a square is a really good technique for working through these graph and quadratics problems. Even though there is a better and faster quadratic formula, the completing a square technique is still useful for problems like these. So if you complete the square, you're going to wind up with the equation of the form, similar to the standard form over here, y equals x minus 4 squared plus 7, telling us that here's our h and the k. The h is negative 4 and the k is 7. It's going to be parentheses. That's our complete coordinate there. So our vertex point thus is negative 4, comma 7, and that's the vertex point of the graph. Now, if you really wanted to go ahead and check and verify your answer completely, what you'd do is you'd find a few points to satisfy this equation up here. Plug in values for x and find out what y would be. You'd graph a few points, form your parabola, and then confirm that the vertex point of the parabola is indeed negative 4, comma 7. We've just done it here using algebra here, finding the vertex point. Given the quadratic here, basically what we did was we first used the average of the roots principle to find the x-coordinate. Then we used the completing the square technique to go the rest of the way to figure out the answer to the problem. This was a graphing quadratics and parabolas problem in Algebra 1.